Have you ever gazed up at the night sky and wondered, what's the story behind that luminous orb we call the moon? Our friendly satellite, ever present, yet carrying a trove of mysteries within its cratered surface. How did it come to be, and what's it made of? And what scientific secrets does it hold? These questions have fascinated humankind for millennia, sparking curiosity and driving exploration. Today we shall embark on a journey to answer these questions. Let's unravel the mysteries of the moon together. Our story begins about 4.5 billion years ago, just after the formation of our own planet. Now imagine a younger version of our Earth, newly formed and still cooling. It's a period of intense activity and change, a time when the rules of the cosmic game are still being written. But our young planet is not alone in its celestial dance. There's another player, a rogue body that's set on a collision course with Earth. This Mars-sized object is named Theia, and its destiny is intertwined with ours. The stage is set for one of the most dramatic events in our planet's history. Theia, with all its mass and momentum, crashes into the young Earth. This isn't a gentle encounter, it's a cataclysmic event, an impact of such magnitude that it would dwarf anything we can imagine. The force of this collision is so great that it literally shakes the Earth to its core. In the aftermath of this cosmic collision, the debris from both Theia and Earth are ejected into space. Huge chunks of molten and vaporized rock are catapulted into the void, a ring of debris encircling our wounded planet. But even in this chaos, there's a certain order. The laws of physics are inescapable, and gravity begins to draw these scattered fragments together. Slowly but surely, this debris begins to coalesce. Over the course of millions of years, these fragments, both large and small, start to merge, pulled together by their mutual gravitational attraction. What begins as a ring of dust and rock slowly evolves into something more, something familiar. Ultimately, this process gives birth to a new celestial body, a satellite that's destined to become our constant companion in the cosmos. This is the birth of the moon, an object that's been a source of fascination, inspiration, and exploration for countless generations. So in a sense, the moon is a child of Earth and Theia, born of a violent and chaotic past. Now that we know how the moon formed, what exactly is it made of? The moon, often considered as Earth's silent satellite, is an intriguing celestial body with a fascinating composition. To begin with, let's talk about the moon's crust. The crust is the moon's outer shell, and it's primarily composed of two types of rocks, basalt and anorthosite. Basalt, a dark-colored rock, forms the flat plains we see when we look up at the moon, often referred to as seas or maria. Anorthosite, on the other hand, is a lighter-colored rock that forms the highlands. Beneath the crust lies the moon's mantle, a thick layer that makes up most of the moon's volume. The mantle is rich in silicate minerals, similar to the Earth's mantle, but with a higher concentration of iron. This iron-rich composition is a testament to the moon's fiery birth, a result of a colossal collision that we discussed earlier. Deep within the moon, there's a small core composed predominantly of iron, but with traces of sulfur and nickel. This core is much smaller than Earth's, accounting for only about 2% of the moon's mass. What's interesting about the moon's composition is how it provides evidence for the giant impact hypothesis. The moon's mantle shares a lot of similarities with the Earth's mantle, suggesting that the moon could have been a part of Earth that was blasted off during a massive impact. The moon's small iron core also supports this theory, as it suggests the moon was formed from the outer layers of the Earth, which are less rich in iron. In addition to these primary components, the moon is also a treasure trove of other minerals, including titanium, aluminum, and magnesium. These minerals are not just scientific curiosities, they hold potential for future lunar exploration and possible resource extraction. Despite its barren appearance, the moon is a geologically rich body with a composition that tells the tale of its violent birth. From its iron-rich mantle to its small core, every part of the moon has a story to tell. A story of a celestial body born from a monumental cosmic event. So we've learned about the moon's birth and what it's made of. But what else have we discovered about our closest celestial neighbor? In the last few decades, scientists have made some astonishing discoveries about the moon. One of the most significant is the presence of water ice at its poles. This was confirmed by NASA's Lunar Reconnaissance Orbiter, which detected bright areas in permanently shadowed craters that are likely deposits of this precious resource. The presence of water ice on the moon is a game changer for future human exploration, as it could potentially be used for drinking, growing food, and even producing fuel. Another surprising discovery is that the moon is not a dead world as we once thought, but it's geologically active. Recent studies have found evidence of tectonic activity with moonquakes shaking the lunar surface. These quakes are thought to be caused by the cooling and contracting of the moon's interior, causing the surface to crack and create shallow moonquakes. So what does this mean for us? Well, these discoveries have broad implications for our future exploration of the moon. The presence of water could support extended human stays, and the ongoing geological activity might offer valuable scientific insights about the moon's interior and the history of our solar system. The moon, it seems, still holds many secrets waiting to be discovered. So what have we learned about the moon today? We've uncovered the moon's chaotic birth, birthed from a cataclysmic collision between Earth and a Mars-sized body named Theia. This violent event sent debris into space, which eventually coalesced into the moon we see today. We've delved into the moon's composition, revealing a barren landscape of basaltic plains, highlands rich in anorthosite, and a mantle similar to Earth's, but with a smaller iron core. It's a desolate world, but one that tells a story of our solar system's violent past. We've also explored some intriguing scientific facts. The moon's gravitational influence results in our planet's tides, and its synchronous rotation means we only ever see one face. Its presence provides a unique perspective for studying our own planet and holds potential for future space exploration. As we continue to gaze up at the night sky, remember the moon's journey from a chaotic birth to a beacon of scientific discovery.